Today, we are diving deep into a new EU regulation that's about to cause a massive headache for anyone working with high-risk AI. We're going to explore how this new law creates a compliance problem that, well, according to our source material, no existing software can actually solve.
All right, let's get into it. We're going to follow a really interesting path here, starting with a single legal word that has a 50-year history. Then we'll look at a universal flaw in pretty much all software, which leads us to a hardware-only solution. And that solution? It might just unlock a brand new, multi-billion-dollar insurance market.
So to really get this, we have to start somewhere you might not expect. Not with technology, but with law. See, the core issue here isn't some newfangled tech problem. It's actually about applying a very old, very specific legal standard to the modern world of AI.
And this is it. This one word, buried deep in Article 14 of the EU AI Act, is the whole reason we're talking about this today. It's the key to everything. Independent.
So what's the big deal with this word? Well, its history is everything. EU regulators didn't just pull this out of a hat. They very deliberately chose a term that has a 50-year litigated history, coming from huge financial regulations like Sarbanes-Oxley. And in that world, independent means something incredibly specific. An auditor has to operate in a completely separate failure domain. In other words, they can't use the same tools, they can't share the same space, they can't be vulnerable to the same points of failure as the thing they're auditing.
And here's the kicker. Article 14 applies that exact standard of independent verification to all high-risk AI systems. And the deadline? It is non-negotiable. August 2nd, 2026. That is a hard date, and believe me, it has the entire industry's clock ticking.
Okay, now let's connect the dots and see how this one little word creates what is, frankly, an existential threat for every single software-based AI compliance tool on the market today.
This brings us to something our source material calls the Turing trap, and it's an idea that goes all the way back to Alan Turing himself in 1936. The concept is actually pretty simple. Any software checker running on the same silicon as the AI it's checking is vulnerable to the exact same errors and drifts. You can't trust the audit because the checker can drift right along with the thing it's supposed to be checking.
And here's why that's a problem in practice. Any software verifier has to go through a whole sequence of steps, kind of like this one. It has to load data, computer hash, load the stored hash, compare them. You get the idea. It's not a single event. It's a slow, multi-step process. And that process takes time. Time when the system is vulnerable.
And that time, that delay, is the entire problem. That whole software song and dance creates about a 5-millisecond window of vulnerability where things can be manipulated. But a true hardware-level check, that can be atomic. It's an indivisible operation that happens instantly, leaving a 0-nanosecond window for anything to go wrong.
And this table just lays it all out. It's an inescapable conclusion. Take a look at all the common tools people are using for AI safety right now. Vector databases, RAG filters, RLHF, the whole shebang. According to this analysis, they all fail the legal test for independence. And why? Because they all operate on the same substrate, the same silicon as the AI they're checking. In the eyes of the law, that means they are not independent. Period.
So, if every software door is slammed shut, what's left? Well, the source material points to one very specific window that might still be open, a hardware-based solution that's detailed in a filed U.S. patent application. The core idea here is honestly pretty revolutionary. It's called S equals P equals H, which stands for semantic equals physical equals hash. What that means is a data point's meaning dictates its physical storage location, which in turn defines its verification address. So in this system, where the data is and what the data is become the exact same thing. This completely eliminates the need for a separate slow verification process.
Now, this is all made possible by a specific hardware instruction called compare and swap, or CAS. It's an atomic operation, meaning it's indivisible and it executes in a single processor tick. With this whole S equals P equals H system, the act of fetching the data is the verification. It all happens in one single instantaneous event.
Okay, so here's where it gets really interesting. This hardware mechanism produces something totally new, data that a reinsurance actuary can actually use to calculate and price risk.
The system spits out something called a cryptographic trust artifact. It's made of 3 parts. First, a measure of structural certainty, which is the core signal for an actuary. Second, a tamper-proof timestamp that's generated by the hardware itself, so software can't touch it. And third, a simple binary pass or fail result. It's not a probability or a confidence score, it's a yes or a no. This data is objective, it's tamper-proof, and it's definitive. Exactly what an insurance underwriter needs.
And that is the absolute key difference here. This isn't software reporting on itself. It's objective telemetry coming directly from the silicon. The source material uses a great analogy. It's like the OBD2 port in your car. That port gives you a direct reading from the engine itself, not a report from the driver on how they think the engine is doing.
So let's zoom out and look at the massive business implication of all this. What happens when you can finally, truly, objectively measure AI risk? Well, you create a market that literally doesn't exist today.
And this is maybe the most shocking number in this whole analysis. Trillions of dollars are being poured into AI, but the current global market for AI liability insurances is zero. Not small, zero. And why? It's simple. Insurance carriers cannot and will not underwrite a risk that they cannot measure.
This unmeasurable risk creates what the source calls a verification gap, this huge operational void that wastes an estimated 30 to 40% of the $8.5 trillion being spent on AI infrastructure. It is an enormous hidden cost that's just baked into the system right now.
And this slide right here shows us a perfect historical parallel. The cyber insurance market was tiny until tools came along that could physically measure network risk. Once that happened, boom, the market exploded from $2 billion to $14 billion in just a decade. AI liability is poised to follow that exact same path the second its risk becomes measurable.
Which brings us right back to this hard deadline. The patent is filed, sure, but the EU's AI Act enforcement date of August 2nd, 2026, that's the real force here. This isn't some problem for the distant future. For any company deploying high-risk AI in Europe, this is an immediate, right-now problem.
And so all of this leaves us with one final critical question for you to think about. The law demands physical independence, a separate failure domain. But your AI compliance stack, like pretty much everyone else's, runs on software, which by definition shares a failure domain. So the question is, how are you going to bridge that gap between the tools you have today and the law that's coming?